rationalize the denominator. What does rationalize the denominator mean? Well, first of all, why would you rationalize the denominator? Because you're not allowed to have radicals on the bottom. That is not in proper form. It will be counted incorrect anywhere in math. You have to get the radical out of the bottom. So then the question becomes, how do you do that? Well, here's an example. This is not simplified because there, as you see, a radical on the bottom. Well, let me show you how you do this. What I'm going to do is I can multiply by 1, right? I can multiply by 1 and not change a number. But if I just multiply this by 1, it would still be 2 over the square root of 5. So I need to multiply it by some version of 1. Well, what I'm going to do is I'm going to take whatever number's here on the bottom, which is the square root of 5, and I'm going to put that over itself. So as you can see, this actually is the number 1. Because anything divided by itself is 1. So the square root of 5 divided by the square root of 5 is 1. So I'm actually multiplying this right here by 1. So I'm not changing it. I'm just going to change the way that it looks. So if you know how to multiply fractions, multiply straight across the top. Well, 2 times the square root of 5 is just 2 times the square root of 5 because I can't simplify that. And then the square root of 5 times the square root of 5 is going to be 5. So there you go. I no longer have a radical on the bottom. How do I know the square root of 5 times the square root of 5 is 5? Because that's the square root of 5 times 5, which is equal to the square root of 25, which is equal to 5. But again, I don't need to do that because I know when I multiply the square root of something times the square root of itself, it's going to be whatever number's in there. That's always going to work. So there's the answer to that. So I'm going to give you one. Well, actually, I'm just going to show you. Here we go. Let's look at one, and the way IXL is doing this, when you will not end up having to rationalize the denominator, but the other way you might. So let me show you how they show you to do it. They break this down into its primes, and you know how to do that. That's going to be 3 times 5, and then they break this one down into its primes, and that's going to be 5 times 5 times 5. And since we know we can rewrite that everything under the same radical, because it goes both ways on that, that's 3 times 5 all over 5 times 5 times 5. And as you know, on canceling, nothing but multiplication up here, nothing but multiplication up here. 5 divided by 5 is 1, and 1 times anything is itself. That means I can cancel that. So I just ended up canceling those, and then that gives me the square root of 3 over the square root of 5 times 5, which is 25. Okay. Break that back down to the square root of 3 over the square root of 25. Well, the square root of 25 simplifies. The square root of 25 is 5, and I end up with the answer being the square root of 3 over 5. So that's fine. There's no radical in the denominator. I didn't have to rationalize anything. I did it IXL's way, and for some people, they like to do it that way, and that's fine. You can do it that way. But let's say we did it our normal way. We're going to end up having to rationalize this. On this one, I end up doing this. I know the square root of 15 does not simplify with prime factorization. And I know when I do prime factorization, the square root of 125 ends up being 5 square roots of 5. But as you remember, you cannot have a radical in the denominator. So I'm going to have to multiply the whole thing by 1, which means it's going to be the square root of 5 over the square root of 5, because that is 1. And where did I pick the square root of 5? Right here, whatever's in the denominator here. Multiply straight across the top, straight across the bottom. Well, that becomes the square root of 5 times, or 15 times 5 on the top, straight across the top. And on the bottom, I know when I multiply these together, it's going to be 5. So I've got this 5 right here. This 5 right here goes here. And then this square root of 5 times the square root of 5, as you know, is also going to be 5. So that ends up being 25 on the bottom. So I just rationalize the denominator there. And up on top, that 5 times 15 ends up being the square root of 75. Maybe I'm done, maybe I'm not. Now remember, this is not 75. This is the square root of 75. But I go ahead and I do my prime factorization on the 75, and it ends up being 5 square roots of 3 on the top, still over 25. So it looks like I'm done, but I still have to look at this part right here. This will simplify. This right here will simplify. 5 divided by 25 simplifies. 5 goes into 5 one time. 5 goes into 25 5 times. I still have my square root of 3. Well, I wouldn't write 1 times the square root of 3 because that also simplifies. 1 times anything is itself. 1 times the square root of 3 is the square root of 3. Still have the 5 on the bottom. And if you look, I end up with the same answer. I showed you this because sometimes you do have to rationalize the denominator. So there's some examples, and if you have any questions, I mean, please practice these, and if you have any questions, let me know. Thank you.